can lease tractors in Europe. People sometimes only buy 2 or 3 of them. But they know, because they can on-sell them, etc., that it's worth doing that. I've had recently lease companies through in Australia, and one of the things they've said with the constrained budgets is you can't really lease rolling stock here like you do in Europe or in the UK. And what that means is a state government, when it buys rolling stock, it's balance sheet debt, not off-balance sheet debt, which changes the complete lease equation in Australia. And that's because we have a degree of lack of interoperability in our passenger vehicles. Ease of obtaining and lower cost spares. If we're making more of them, the spares will be cheaper. We're not starting up a production line for spares that we have to start up every 15 years when you want some. So that's one thing that's very good about it. Reduced driver training. It's the same cab at every track, whether it's SNCF, whether it's Deutsche Bundesbahn, it's the same cab, whether it's a private operator. And that's a good thing. That's something we do well in the freight market in Australia. The passenger market is not the same thing though. Reduced obsolescence risk. If there's 800 out there, somebody's going to design you a spare part. We've got the problem with the traction drives at the moment in Adelaide. You can't get the Thyristas anymore, but it's the only drive of its type in the world with those drive boards. So if you're going to design a spare part for that railway, you'd be designing that vehicle, you'd be designing it just for that vehicle. And also things like manuals, be they driver's manuals, repair manuals, etc., get better the less specialised each piece of rolling stock gets. Basically, can we make it out of the toolbox of equipment? So the first thing here is, will it fit the infrastructure? Now, from a designer's point of view, I've stated what it is. Now, a lot of people, we think of Perth and Brisbane as similar systems, and in many respects they are. But one thing is crucial, and that's here, is it's a different body side profile. As soon as I change that, everything changes. For a lot of them, most of the drawings and most of the design time of a vehicle. So if I make a particular profile vehicle longer, or I add a bit of width in it, that's one thing. Change the body side, that is a more major cost implication for people out there. Now, a body side tooling jig, if you want a flat body side, is over $1 million. So I prefer, if I can shorten my vehicle, if I can make it wider, but please don't change the body side profile on me, please, because that has far more major cost implications. So here you can see, although we're talking systems, 25 kV, 3'6", same bogie centre, same everything else, we end up with a different vehicle. And that vehicle will cost 100 to 150,000 hours to design. Easy. So here we go, different sets of drawings, UFE analysis. So, that's all your structural analysis. Use strain gauge test. I've had a guy working for 6 months just designing the strain gauge test room. Different tooling for car shell structure at manufacturers and suppliers. I've already mentioned that. So the profile changes your roof and your floor. All the redoing of production planning, new procurement, going out for new quotes. And the more you redesign something, the more it impacts cost and delivery. And that adds cost to the vehicle, it makes it more expensive, it's more likely to be late, you're more likely to end up on the front page. So there's a whole load of implications running through that every time we do design changes. Even internally, most manufacturers, the more design there is, the more risk premium we have to build into the price, the more expensive the vehicle gets. Now, we've got the potential to use the same bogie in Perth and Brisbane. I know in our case that's not the case, but there's the potential for it. There's the potential to use the same motor, gearbox and wheel set, so the overhauler is overhauling the same. If we're the maintainer of the vehicle, it means we may have to hold a lesser stock holding for rotables, which is a good thing. And also insurance spares. We have the potential to use the same suspension setups, which reduces the costs of modelling and everything. And again, reduced impacts on cost and delivery. Now, you can undermine things. Now, quality of infrastructure maintenance can affect bogie selection or affect suspension components within the bogie. A good example of how cost is put throughout the world is the Melbourne tram system. The Melbourne tram system is the design case for our new bogies. Worldwide, we have to design them to be strong enough to take Melbourne. So that cost is being put all over every tram project in the world. The fact that the Melbourne track is rather shoddy in the tram area. So that's one area. Customers have own requirements that are non-standard in industry areas such as wheel unloading. I won't name the railway, but there's one railway in Australia that has a different wheel unloading requirement to everybody else, which is a bit more stringent. And as I said, high ride requirements and low quality infrastructure. What I was mentioning, we've got a de facto standardisation at the moment nationally in fire specs. And this is why sometimes thoughts needed too. This is not, everybody is going for BS6853 as our fire spec nationally at the moment. You're seeing it in Queensland, they're talking about it in Melbourne, it's already in Adelaide, and they asked for that in Rapcore. That sounds all great until you can't test any component in Australia. So we are sending work that could be done by Australian suppliers to the UK or overseas simply because they can test to that standard and Australians can't. So the only way we can get Australian suppliers is try and develop them. So there's a barrier for entry for Australian rolling stock within Australia for our supply base. And it's been created by a standard filling a vacuum. So although we're getting compatibility there and interoperability, because we've actually gone the wrong path, we're actually getting a cost on all our supply base and Aussies are actually losing jobs. So train performance, will it brake fast enough and accelerate from the stop? Fortunately here, the fundamentals of the wheel rail interface and also a lot of similar signalling systems mean here we can actually start getting some degree of standardisation here, which is good. And there's compatibility between vehicles. You could run, shall we say, a Perth vehicle, a Queensland vehicle in Perth. You can do that. Okay, there's some gauge problems, but fundamentally a lot of the architecture is the same. So realising interoperability. So as you can see, there are a number of areas of the design which now have commonality benefits appearing for level 3. We've got same bogie, same motor, same traction control, which is good. We've got the same traction inverters in Perth and Brisbane on the vehicles. Potential to use the same pantograph, 25 kV. Potential to use the same brake equipment. And again, an example of how to do it wrong. I've had Knorr sit down there in a meeting to me saying, why do I need to supply a full shadowing brake system for one market in the world? Why does one state have a different brake system from every other state? It's a good question to ask yourself. Signalling compatibility. Again, because we've got a degree of, shall we say, systems that are seen overseas, our traction supply can actually maintain, and as I said before, we actually have the same traction inverter. So what you're seeing is a lot of the underframe equipment, as long as we don't have things like full shadowing and that kind of thing, we can have commonality across vehicles. Interoperability for us, crew interface. What does the driver need to drive the train? So there exists the potential to use the same cab over different contracts. If a driver hops in an SCT class loco, which has been bought by other people, they hop in the same loco. If they hop in a train in Melbourne, even between V-Line and MTM, it's different. They hop in a train between different states and it's completely different. So we've managed that very, very well, that kind of interoperation, shall we say, between in the freight sector, but we haven't done a very good job of it in the passenger sector, with everyone being an individual. And that costs money. It costs money and time spent in cab committees. And the solution never ends up being ideal if you're starting from scratch every time. It's never as good a solution as one that evolves. Our perspective as a manufacturer, design, the more interoperable things are, or even, shall we say, similar rules governing similar systems, basically there's less uniqueness in there. To be honest, the uniqueness is a barrier for entry for alternative players, to be honest. But, you know, it's better if we're creating products that are better value for our customers. You know, if a train is cheaper, you will buy more of them. At the moment, as people point out here with locomotives in this country, you know, a American loco is a lot cheaper than one made in Australia. So, build, tooling and production planning are simplified if we have this degree of commonality. And interoperability can drive that. Maintenance, better documentation for the workforce, easier to obtain cheaper spares. There's a lot of benefits that start flowing out there. Operator, less driver training, less delays into service, easier financing, you know, fewer IR issues. If you've got a standard CAD, you're spending less time in CAD committees. And potentially less rateable items required. So there's a lot of benefits if we start thinking not only of our interoperability in terms of signalling systems, etc., but also what we specify and put onto vehicles as well. Thank you.